February 19th. You know, the work just gets later and later. Okay. Yeah, it just gets later and later. I finished today, I think around 10. Oh, I think no, 10:30. About 10:30 I finish, and then I eat, and now I'm doing this. It's a grind. It's a grind. The work is always a grind. Find unique binary string. Given an array of strings nums containing n unique binary strings, each of length n, return a binary string of length n that does not appear in nums. If there are multiple, you may return any one of them. Okay. Well, I mean, it's there is a very easy way to do it, because 16, 2 to the 16 is within our reach, because 2 to the 16 I think is not that big, right? And we intend just to go through them one by one. Wait, what's 2 to the 16? Is that 700 something? No, 700. Jesus, 665,000. So yeah, so the worst case scenario, we just go 65,000. We just go through them one by one, and yeah, it's not that bad. We can definitely do it, and we just need to figure out the starting and end point. Just start from 1. Right, we start from 1 and then we end at 2 to the n minus 1. Right, 2 to the power of the n minus 1. So in this case, we basically start from 1 and then we end at 7. We just go through every one, and the first one that does not exist, that's the one. Right? All we need to do is to know. I will turn this into a set, and I just need to know, how do I convert integer into binary string. Integer to binary string. Change integer to binary string of digits. Bit set. No, that was too long time ago, right? Yeah, it's more than 10 years ago. All right, so basically we use bit set. I can turn this into, okay, what is bit set? 64. Bitset to string will return the binary representation padded. Since bitset is returning the binary representation of the set, that is exactly what it should return. But if someone is misusing bitset to convert ints to binary string representation, they will call the output padded. Outputs is this. Isn't this what you wanted, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, it's 16. So basically, bit set, this is, which we'll put n to it, and then we go through, then we get the string. Ooh, that actually make it pretty easy, right? Pretty simple. That's good. That's exactly what I want for today, because it's late. I don't want to do much today. Probably get this one done, and then we'll call it a day. It'll be fast. All right, let's see. We shall say std a set of string, right? Scene. We'll say nums.begin, nums.end. I'm not sure if that's the syntax, but maybe. And then we say int n equal to nums.size. Okay. And then for int I equal to, so can we do 0? Zero would also be correct, right? So I can do 0, I smaller equal to 1 left shift n minus 1 I plus plus. And we say if std bit set n. Okay, what do we do? Bit set. Oh, bit set and directly call it something. All right. So we say this we're gonna call I. So if scene dot contains this, right, does not contain, now we return. Okay, so how do I define it? Yeah, I think it should be bit set and b I can just go with a string. BSTR shall equal to this. No, we don't need to do this. Dot to string. Not sure if the syntax is correct. Maybe it does not have it. Alright, I don't know. I think this is too old. Bit set num bits. No, it is right. std bit set num bits number dot to string. None type template argument is not a constant expression. Huh? What? Bit set none type template argument. None type template argument is not a constant expression. Not a constant expression. Oh. So I can say constant int. Can I do that? Constant int? I mean, it is a constant, right? constant expression must be initialized by a constant expression. Ah, this is not good. This is not good. I don't have. This is not a constant expression. All right, I need another way. This doesn't work. All right, we're back to square one. Yeah, I might eventually have to do something like this. Okay, I don't want to. Let's see. Binary string, a bit set with dynamic size. Vector bool. Okay. I think. Substring. We can do substring. Yes. Substring. Substring is the start and end. No, it's the start 0, 1, 2, 3, 4, 5, 6, 7, and the length 1, 2, 3, 4, 5. Okay, that shall work. Then I don't even need. I do need this, but this I'll do 16. Okay, I do 16, and we can say that sub. Dot sub str. It will always be the starting point will be 16 minus n and n, right? Let's see, 1, 2, 3, 4. Let's just give an example, right? 5. 1, 2, 3, 4, 5. So let's say I want 3. So 5 minus 3 is 2. So 0, 1, 2. We start from here getting 3. Yep, I think that's correct. So this is getting the binary string. And then we say if it does not contain, and I'll just return it. Otherwise, I just keep going. Would it be possible that nothing gets out? Well, I don't think so, because num's length is n. Right? Num's length is n. And the total should be 2 to the n. So you'll always be. But I can say return this and say should not hit here. All right. $19.80. Turn nums into a set and iterate through all possible numbers between 0 and 2 to the n minus 1. We use bit set, right? bit set 16 to convert an integer to its 0 padded binary string. O 2 to the n. Alright. Okay. Let's hope we get this one in one shot. I don't know what that is. I think it's, I forgot to delete everything. You have attempted to run too soon. Okay. Now. Alright, looks solid. Let's submit it. Yep, looks good. Previous submission, 2023. I don't know why it runs so many times. I did a Java. Probably just... Ha! Ha! I tried this method. Oh my. Oh, I already forgot about the Java link. Syntax. Can we get a random? I just keep calling next int. But how do I decide? Oh, I have a max. Oh, I see. Yeah. Ah, that's great. That is great. I don't understand this thing. Nums.length. And then we format. Oh, that's probably just turned it into pat some zeros. That's what I think. Okay. What else did I do? I do a set. I start from here. I just go through. I guess pretty much that's the one. N squared. Oh, that's a different solution. Oh. No, I think it was wrong. Generate. It's not 2 to the n? Oh, it is not, because this is really you try every single position, right? At 0. And this is if it's successful, right? And if it's not successful, we'll add 1. And each time I am going to check Oh, this actually goes all the way to all the way down. Huh. But I go all the way down. Isn't this still 2 to the n? Because at each position you have two ways, right? You either do this or you do that. So this is basically backtracking. No, I think it's 2 to the n. It's not n squared. Oh yeah, that's definitely wrong. Oh, infinity. Cantor's diagonal argument. I feel like I've seen this one before. Yeah, nobody talk about the in the worst we generate n+1 strings. Huh. I think it may be n squared. But if you fail, you have to come back. Right? We do that. You do uncall of this, and at the end you will check. If it's not good, then you do the other, you go the other one, and if it's not good, you go back, check the other one. No, this is crap. This is not right. It's 2 to the n. It is 2 to the n. This is not right. But hold on. Because the size is only n. Oh, the size is n. If the size is n, then it's either... Oh, okay, yeah, this is also good. Oh, then this is not 2 to the n. This is also... Because you only need to go through n times. This is O(n), right? Because the set is only this big. So the worst case is to go through n, so yeah, this is O(n). And of course, you also need to consider the conversion time. Very good. Oh, I didn't realize it's also dependent on the size of size of nums. Yep, it's O(n). That is true. What's this Cantor's thing? Oh, so each one we just change, right? Yeah, we just change at each position. For the first one, we change, and the second one of the second, third one of the third, fourth one of the fourth. Yeah, I think this is also how we prove like infinity. At each position, you choose a different number, right? So the generated one will be different from everybody else. This is a yeah. Now you can create a new. Yeah, that's how you prove infinity, right? You can always create like why how do you prove that there are the proof that there are infinite number of integers? You use the same idea to do the proof. This is Cantor's diagonal argument. I'm actually want to implement this. I mean, it's not that hard, but it's interesting. Something to keep in mind. And this is actually not. This is actually on because num size is n. This means we only need to iterate through at most n plus 1 values to reach an answer. Okay. Oh, this is not what we want. So this one we say using Cantor's diagonal argument, we create a binary representation such that the ith bit is different from the ith bit of the ith number. So we get a res right, and then we say char c equal to nums I res plus equal to c is equal to 0. If it's equal to 0, we do 1. Otherwise, we do 0. Oh, that's solid. Yeah, that's solid. Alright, that will be it. I'll see you guys tomorrow. Adios.